Hello everybody. In this spreadsheet tutorial, we're going to go over the present value function and the future value function. We will be using numbers for the Mac. However, for the most part, this should work the same in Google Sheets, Spreadsheets, and Excel. Let's go over a quick definition and a few notes. The present value is the value today of a future payment or payments discounted at some rate. And you can kind of think of discounting as interest being applied but in reverse. The present value method is often used to determine how much money should be invested today to result in a desired or needed amount at some point in the future. So for example, the present value of $100 to be received 10 years from now is about $38.55 using a discount rate equal to 10% interest compounded annually. Or another way to think of that is you would need to invest $38.55 today in order to receive $100 in 10 years using an interest rate of 10% compounded annually. The present value method is widely used in corporate finance and security investments to help make decisions about investments. Okay, so that's the present value function. Now you can just simply think of the future value function as the present value function in reverse. Okay, so let's use our example here and plug in these numbers to our present value functions and our future value functions. The present value function takes 5 arguments: the periodic rate, the number of periods, the payment or payments, the future value, and the when due. Now some of these arguments can be optional. So for example, you don't necessarily have to put in a payment argument or a future value argument, but as far as I know, you cannot leave both of those blank. So you need to put in one or the other or both. Okay, so let's put in our periodic rate. The rate is going to be the interest rate, and we said down here in our example that's 10%, and we're going to put this in as a decimal. So let's put in 0.1. Okay, so there's 10% for the periodic rate. The number of periods we said is 10 years, and since it's compounded annually and not monthly, that will just simply be 10 for 10 years. There are no additional payments, so we can put in 0 for that. The future value, we said that the present value of $100 to be received, so the future value will be this $100 because we said to be received. So we put in $100 there. And there are 2 options for the when due, and that has to do with when payments are put in, either at the beginning or the end of the period. And since we're not putting any payments in, we can leave that as the default, or let's just go ahead and put a 0 there, because I believe that's the default. Now let's go ahead and use our present value function, and to do that we're just going to hit the equal sign. We're going to type PV for present value. We'll hit enter. And now we need to put in all of our arguments. So the first argument is the periodic rate, which is here. The second argument is the number of periods here. Third argument is the payment, and there were no payments. The fourth argument is the future value, which is the $100. The when due, and let's just show you, if you click this little arrow for the drop down, the end of the period, if you were to put that in, would be 0 or omitted, and the beginning of the period is 1. Okay, so we'll just keep that as 0. Now we'll hit our check mark, and if we've set this up correctly, we should get $38.55. Okay, and we do. Now one thing you might notice is this is showing up as a negative number. And the reason this is showing up as a negative number is because this is considered a cash outflow. This is considered an investment, so this is coming out of your pocket as a negative and going into the investment. Okay? And we'll discuss that a little bit further in our future examples. Okay, so now let's go ahead and set up our input parameters for the future value function, and you're going to see how closely these 2 functions are related. So again, the periodic rate is 10%. The number of periods is 10. Again, there are no payments. Now for this present value, let's just go ahead and copy the present value from our present value function and put that in here. Okay, so our present value is $38.55, showing as a negative because that's coming out of our pocket and going into the investment. Again, we'll just put 0 for when due. And now let's use our future value function. So hit the equal sign, type FV for future value. Let's put in all of our arguments. And again, if we've set this up correctly, now we should get $100, which is basically what we did over here, but in reverse. Let's hit the check mark, and we get $100. Okay? So now let's move on to another example. Okay, so in our first example, we're going to use the present value function. Here is the example we want to use, and this is very similar to the default example that is used with the numbers spreadsheet. So if you ever want to check this out and go over it in a little bit more detail, just call up the function and go to your sidebar, and you can see all the information here on the sidebar for the present value function. Okay, so our example says you want to make an investment. You will invest for 15 years, and there's something specific we need to do to the number of periods, and we'll go over that here in just a second. And you want to have $150,000 at the end of your investment. So at the end of 15 years, you need to have $150,000 for whatever reason. It could be for your kids' college. It could be for the next home you'd like to purchase, a vacation home, some amount of money you want to donate to charity. Whatever your savings or investment goals are, just know that we want to have $150,000. You can contribute $200 to the investment at the beginning of each month. And over the next 15 years, the investment is expected to earn an annual interest rate of 4.5%. And it earns interest on a monthly basis. And that's kind of important to know, and we'll tell you why here in just a second. Okay, so now let's go ahead and put in the values for our arguments. So as we mentioned, the interest rate, or the periodic rate, up here in our example is 4.5%. But since our interest is being paid on a monthly basis, we need to divide that 4.5% by the number of months in the year, which is 12, and that will give us our periodic rate, or our per period interest rate. So let's go ahead and put in the 4.5%. So let's put in a decimal, 0.45, and let's divide that by 12 months. Okay, so this will give us a per period, or a periodic interest rate of 0.375%. The next thing we need to do is figure out our number of periods. And we said in our example that we have 15 years to invest. But again, since we are earning interest on a monthly basis, that will be 15 years times 12 months. So let's hit equals, type in 15 times 12. And this will give us 180 periods where our investment can accrue interest. The next thing we need to do is put in our payment. And we said that we can contribute $200 per month. And since this is an investment, this is considered a cash outflow. This is coming out of our pocket. We need to put this in as negative 200. Okay, so the next argument is our future value, and this is our goal. And we said that we want to have $150,000 at the end of the 15 years. So here we put in $150,000. Next, for the when due argument, we need to put in a 0 or a 1. And since we said that we will be contributing $200 to the investment at the beginning of the month, 1 equals beginning of period, so we're going to put in a 1. Okay, so now let's call up our present value function. Hit equals, type in PV. Let's put in our periodic rate of 0.375%. The number of periods is 180. The payment is negative 200 as a cash outflow, or an investment. The future value, or the goal amount we want to achieve, is 150,000. And the when due is 1. Okay, so let's hit our check mark. And we get an answer of $50,227.88. Okay, so this $50,227.88 is the amount that we need to invest today in order to achieve our future goal amount, which is $150,000. Now, of course, that's assuming that all of these input parameters apply. So if we are to invest $50,227.88 today, and we have 15 years to invest the rest of our money, and we contribute $200 per month at the beginning of the month at an interest rate of 4.5% that earns interest on a monthly basis, then we will meet our future value goal. Okay? Okay, so now let's go over our future value function. And as we mentioned before, the future value function is very closely related to the present value function, and you can almost think of it as the present value function in reverse. Okay, so here is our example. Again, you want to make an investment. You will invest for 15 years. You have $50,000, that's your present value, to set aside for the investment today, and you can add $200 to the account at the beginning of each month. Over the next 15 years, the investment is expected to earn an annual interest rate of 4.5% and pays interest on a monthly basis. Okay, so you can see this example is very similar to our previous example. So let's go ahead and put in our input parameter values. So the periodic rate is the interest rate, and again, that's going to be the 4.5% annual rate divided by 12 months to give us the periodic rate because the investment pays on a monthly basis. So let's put in as a decimal 0.45 divided by 12. So our per period or periodic interest rate is 0.375%. The number of periods is the same as it was before, so that's 15 years times 12 months, so it should be 180 periods. Again, we're going to make $200 a month payments. We'll put that in as a negative because that's the investment. And just in case I didn't mention this before, you see this present value comes out as a negative, and that comes out as a negative. That's because this is considered a cash outflow or an investment, and this money here would need to be invested and come out of our pocket and go into the investment, and that's why you'll see a negative there. Okay? So back to our future value function, the present value, let's go ahead and put in a cash outflow or investment number of negative 50,000. And again, we're going to make our payments at the beginning of the month, so we'll put in a 1. And now let's call up our future value function. So in our cell, let's hit equals FV for future value. Let's put in our periodic rate of 0.375%. The number of periods is 180. The payment is 200. The present value or the investment is 50,000, and the window is 1. Let's hit our check mark, and we get a future value of $149,553. Okay, so this is the expected value of the investment after 15 years according to all of our criteria. So, for example, it must be 4.5% interest rate, compound on a monthly basis, be able to accumulate interest for 15 years, we must put in $200 per month, and so on. Okay, so just to show you how closely related these two functions are again, if we take our present value amount from the previous function here, and put it into this future value function here, you can see that all things being equal, the present value and the future value numbers are the same. So for the future value here, we have 150,000. For the future value here, we get 150,000. And the present value numbers are identical as well. Okay? Now, one thing to note, these are just a couple simple examples of how you can use the present value function and the future value function. There are many other ways that you can use these functions, and also remember that you don't always have to put in all of these arguments. So for example, you don't always have to put in a payment, and you don't always have to put in a future value, but as I mentioned before, I believe you have to put in at least one or both. It really just depends on what you're trying to figure out. So that's all we have for this spreadsheet tutorial on the present value function and the future value function. We will be doing many more spreadsheet tutorials in the near future. Join us for those, and we'll see you next time.